Hello everyone. Write down the escape velocity. This is Earth. Mass m, radius r. An object of mass small m is projected with speed ve. This ve is your escape velocity. You need to find ve. And what is the meaning of ve? This v is minimum speed with which you can throw an object from the surface of Earth so that it doesn't come back. Write down the statement. Escape velocity is the minimum velocity. Escape velocity is the minimum velocity with which an object should be projected so that it does not come back. So that it doesn't come back. Now, when you say that this object is not going to come back, then it only means that this object reaches infinity. At infinity, gravitational intensity due to any body is what? Zero. This is g at infinity, which is zero. If there is no gravity present, then this object will never come back. Now, why do we say that v is minimum? Why not simply any velocity? Why minimum? Let's say, just for your understanding, let's say this v is 15. With 15, you can cross infinity and move to the other side. Although it's not correct to say that you can move to the other side of infinity, because infinity means something, a place which is at a very large distance. So, but just for the logic present in the question, right at this place gravity becomes zero, and after that it is definitely what? Is zero. So when you throw the object with 15, it reaches this place, and when it reaches the place, speed is 2. Since object still has some speed, it can cross and reach the other side. Let's say when it reaches over here, speed becomes 0. So it started with 15, 14, 13, 12 and so on, 2, 1, 0. It is at infinity and therefore gravity is 0, it will never come back. But we have given the object extra speed. It could cross and enter this region. What if I give it 14? If I give it 14, when it reaches this place, it becomes 1 and then it becomes 0. So this is also what? An escape velocity type of thing. But if I throw this object with 13, what I found that at infinity its speed becomes what? 0. Then after 13, if I say speed is 12, then somewhere at this place speed becomes 0. It is not able to reach infinity. Before even reaching infinity, speed becomes what? 0. But this is some place where gravity is not 0. At this place, G is not 0. Gravity is present and therefore this object will ultimately fall back on the surface of Earth. So what is the speed with which you can throw an object and it can reach infinity? 13, 14, 15, 16 and any number you can take above 13. But what is the minimum you can throw an object will not come back? That minimum is 13 and this 13 will be called what? V. We are interested in this minimum number. This is how you understand meaning of minimum. I hope everybody is comfortable with this. Now, the question is we need to find V, which is the minimum speed you throw an object, it reaches infinity, and I have told you that when it is at infinity, V at infinity will become what? 0. The other hint for finding V is once you throw the object, once the object leaves your hand, W external is 0. You gave this object some speed which is V. The moment it leaves your hand, W external, that point onwards becomes what? 0. If W external is 0, we will use COME. Answer V in the comment box. Note down this much. Find out V. Good. Many of you have solved this thing. So how do you apply COME? What is kinetic energy at this place? Half mv square. What is potential energy? I hope you remember everything regarding potential energy, how to use potential energy and all, which we did in the previous lecture. Potential energy for this type of setup, when things are moving for such a large distance, right over here, potential energy is minus of Gmm divided by R. That's how we write potential energy. At infinity, what is kinetic energy? 0. What is potential energy? That is also 0. This is the simple derivation for escape velocity. M cancelled and V is coming root over 2Gm by R. That's your V. Kinetic energy initial, potential energy initial, kinetic energy final, potential energy final. We take potential energy at the surface minus Gmm by R, provided at infinity it is 0. That's your V. Note down this. Those of you who could not answer this, if you understand this derivation, then write down yes in the comment box. Now this Gm by R, if we have some mass which you place right at the surface M, then force on M is what? mg naught. Weight of an object is what? mg naught for gravity at the surface. But this mg naught is also equal to what? gmm divided by r square. If object is outside, entire mass of earth can be placed at the center as a point. What is the distance between this point at the center and this point? Capital R. So what is the force? gmm by r square. It tells you that m and cancel. Your g naught is gm divided by r square. G naught is gm by r square. So you can do this. You can write after this, use an equal sign and then do this. Multiply with r, divide by r. Gm by r square is now 2 g naught multiplied by r. Why did we use this? It's easier to calculate this value for the earth because we have g naught, we have the value of r. This is 2 g naught, you know, is 9.8. Capital R is 6,400 kilometers. Multiply with 10 to the power 3. This is kilometers and you need to multiply with 3. This is coming around 11.2 kilometers per second. This is not meter per second. What is this? Kilometers per second. For any other planet, find out value of g naught. Suppose somebody throws the object from the surface of moon. You'll be using g naught at the surface of moon, r will be the radius of moon, and you will find the result. For earth, this is coming 11.2 kilometers per second. Note down this also. Answer this. If we increase the mass of object, this is projectile which you are throwing up. If you increase the mass of projectile, then what happens to escape speed? It increases or decreases? If we increase mass of the projectile being projected, then what happens to speed of projection or the escape velocity? Good. Everybody can see that small m and small m, they are getting cancelled. So if m is getting cancelled, that means this expression for escape velocity is independent of mass of projectile. It does depend on mass of the planet, but it doesn't depend upon mass of projectile, thing which you are throwing up. Write down this. Escape velocity is independent of mass of projectile. escape velocity is independent of the mass of projectile being projected. Now answer this. If instead of throwing it vertically up, if I throw this object with V and I need to find V, and let's say this angle is 45 degrees. If angle of projection is 45, instead of throwing object vertically up, if you decide throwing it at some angle of 45 degrees with the horizontal, then what will be the value of V so that it can escape to infinity? Good. Your answer is that your V still remains what? Same. Why? Because this is E, energy, and energy is what? Scalar quantity. If you throw this object up or in this direction or in this direction or in any direction, its kinetic energy will be half mv square. And as long as object is on the surface of Earth, potential energy will also remain same. Once it reaches infinity, these things they become what? Zero, and therefore there will be no change in the magnitude of V. Therefore, at times instead of saying escape velocity, we also call it escape speed, because it doesn't matter in which direction you are throwing the object, as long as speed from the surface of Earth is 11.2 kilometers per second, this object will ultimately reach infinity. So write down this statement, also draw this figure as a separate figure, draw this thing and then write down the statement. Escape velocity is also independent of the direction of projection. Escape velocity or magnitude of escape velocity, is independent of direction of projection. Answer this. If we, instead of throwing the object from Earth's surface, if we drop it from infinity, if object is dropped from infinity, slight push, you drop the object from infinity. It falls and hits the surface. With what speed this object is going to hit the surface of Earth? Remember what the question is. Dropping the object from infinity, just don't assume that since g is 0 it will not come back. At infinity you gave it slight push. Just at infinity g is 0. 1 millimeter below g is present. The small push which you gave means gravity is present, and then that gravity will keep on attracting it, and ultimately it will fall back over here. So when you drop it from infinity, with what speed this object is going to come back? Well, I've got only one answer, and that also is not good. The answer is V. Answer is root over 2 gm by r. It's the same thing. When you throw an object up, and let's say it starts with 12 meters per second, if an object goes up with 12, then it also falls back with the same speed of 12. Same thing is happening in this. If you project with VE, then it reaches infinity. If you drop it from infinity, then it will come back and hit the surface of Earth with same speed. Why? Look at this same equation. This was the initial side and this was the final side. But now let's interchange these things. इस बार हमने क्या बोल दिया? हमने बोला कि ये वाली जो side है, this is the initial one. Initially kinetic energy is 0 at the top, at infinity. Initially potential energy is also what? 0. When it hits the surface of Earth, kinetic energy is what? Half mv square. Potential energy is what? Minus gmm by r. So when we developed function of V, this was initial, this was final. For this question, this side becomes initial, this side becomes final, but your result remains what? Same. Something which you have already seen in projectile and in motion under gravity, in kinematics, things like that. In projectile, when you throw an object with you, it arrives with you. In motion under gravity, in the first kinematics, when you throw an object up with you, it comes back with you. Same is the case here. You're throwing an object up with you and it is coming back with you. So write down the answer. That answer in this case is again what? Root of 2 gm by r. Now answer the next question. Well, this is something you can expect in any examination, school, NEET or JEE Main. Write down the question. An object is thrown up with half of the escape velocity. An object is thrown up with some velocity which is half of what? Escape velocity. Find out maximum distance of this object from the center of Earth. An object is projected up with velocity which is half of escape velocity. Find out maximum distance of the object from the center of Earth. Let's see how many of you will answer this question. Not a single response so far. Go down the hint. Hint is SUME. That's the hint. This time object is not reaching infinity. Let's say it goes up and comes at instantaneous rest. So the place where it comes at instantaneous rest, let's say its distance, well, there is enough hint I have given to you, and I hope you can answer this. Only one response, but that response is also not dimensionally correct. The answer which you have given is meter divided by meter sort of, and therefore it's not the correct value. Just check your calculations again. We're using COME, and the question says that you are throwing the object with some speed v, which is VE by 2. It reaches here. At this point, its speed becomes 0. Let's say final, initial. Initial is half of escape. Finally, it becomes 0. Since it's half of escape, it's obvious that it cannot reach infinity. And you also cannot say that it will reach half of infinity. कि भाई हमने जब v से थ्रो किया था कहाँ जाता था infinity, half कर दिया half of infinity, because half of infinity is also infinity. So the logic is, right at this place, question says find out distance from the center. I'm looking for r. एक जो कॉमन मिस्टेक यहां पर लोग करते हैं वो क्या है, the common thing is people take height from the surface h and then they answer h only. But if you look at the question, I'm asking distance from the center. So it's better you take distance r from the center. And then use COME. What is kinetic energy? Half of m v by 2 whole square. What is potential energy? Minus of g mm by r initial. Finally, what is kinetic energy? 0. It reaches this place, comes at instantaneous rest. This is the maximum distance. And then it starts falling towards the earth. So what is the maximum? When its instantaneous speed becomes what? 0. And what is potential energy? Minus of Gmm divided by r. Just because it's v, you should not write 0 because the object is not reaching infinity this time. It is at some distance r from the center. If you are outside, then entire mass can be considered at the center as a point. And what is potential energy of 2 point masses? This. Solve this and you will get the answer. This is coming half of m. What was v? Root 2 gm by r. Square will be 2 gm by r. Divided by 2 square, which is 4. Minus of gmm by r equals to minus of gmm by r. V, we already know that V is root over 2 gm by r. It's a square, and then divide by 2. This becomes this. You can cancel the terms of gmm, gmm, gmm. All these terms you can cancel. This becomes 1 by 2 minus 1. Not 1 by 2, 1 by 4. 2 and 2 cancelled. This is 1 by 4 minus 1. Take this r out, equals to minus of 1 upon r. Simple maths कोई भी कर सकता है. So I hope you can see that r is coming 4r divided by 3. This is 3 by 4 minus cancel. We are looking for a small r, which is coming 4r by 3. If you understand everything, then write down yes in the comment box. Now write down orbital velocity. This is Earth, or can be any planet of mass m and radius r. This radius is r. And mass of the planet is m. We have an object, or simply a satellite, which is orbiting around this planet at a distance of r. This distance is r. And right at this place, it is moving with V O, O for orbital. Mass of the satellite is m, and it's a circular orbit around this planet of mass m and radius capital R. We have a satellite of mass m which is orbiting with orbital velocity VO. You've got 30 seconds time. Find out what VO is. What is VO? Just remember that this is the circular orbit. Good. Since it's a circular orbit, let's say that the satellite is found at this place. When satellite is at this place, it is being pulled towards the center of Earth. This satellite is being pulled in this direction toward the center of Earth with force of gravity Fg. Anywhere in the orbit, the force of gravity is what Fg. But this force of gravity in circular orbit is going to provide Fc. What is C? Centripetal. Force of gravity is not balancing centripetal. We say that force of gravity is providing what? Necessary centripetal force. When you say, and they can ask you a question like this, is it correct to say that force of gravity is balancing centripetal? Now, if they balance, then balancing means what? Let's say 10 is acting up, 10 is acting down, that is called balancing forces. But what is the net force? 0. But is force 0 on the satellite? No. What is the force? Fg. What is the force? Fc. That Fg is same as Fc. जो अर्थ का ग्रेविटेशनल पुल है उसकी वजह से इस ऑब्जेक्ट की डायरेक्शन लगातार क्या हो रही है? चेंज. डायरेक्शन चेंज करने के लिए जो फोर्स होता है दैट इज कॉल्ड व्हाट? सेंट्रीपिटल. सो रिमेंबर दिस एंड विल आल्सो राइट द स्टेटमेंट. F gravity is what? F centripetal. How do you find F gravity? Anything which is outside, if you want to find force on it, Earth should be kept at its center. Provided, remember again and again, if things are outside. So, and satellite definitely rotates outside only. So, what is force of gravity? Gmm divided by, now, many times people simply go for r square and they use capital R. This object is moving, this satellite is moving at a distance of r from the center. So use small r. This is force of gravity. What is centripetal force? mv square upon r. Which v? VO. MM cancelled and VO is coming root over GM divided by R. That's your orbital speed. And look, as I just mentioned that people write capital R, and 4 or 5 answers which I have got so far, everybody is using capital R. Capital R means your satellite is orbiting very close to the surface of Earth. No, the satellite is revolving over here. So this is that kind of silly mistake which normally people commit. So I hope you will remember this. Gmm by r square, not any r. This distance, which is small r. What is capital R? Radius of the Earth. I'll note down this. Only 2 answered correctly. And I hope all others who use capital R and those who didn't answer anything, I hope they understand each and everything. Now find out angular velocity of the satellite. Answer this next part. What is the angular velocity of satellite in its orbit? Write down the question. Find out angular velocity of the satellite in its orbit. Only 2 responses. How do you find angular velocity? Angular velocity omega. What is the relation between V and omega in circular motion? V equals to r omega. Remember, don't use capital R. This radius is r. So I'm asking you, What is omega? And everybody has to use this. V equals to R omega. What's the value of omega? V divided by R. What's the value of V? There. So this is coming root over Gm divided by, you already have one term of R. You need to divide that with this R. Keep the R inside, make it R cube. That's your omega. Root over Gm divided by R cube. This is V. When you divide this thing with R, you can take the term of R inside, make it square. R is already present. That becomes what? R cube. That's your omega. Now answer the next part. In what time this satellite will complete one rotation? In what time satellite is going to complete one full rotation? Look, how do you find time? Time is distance divided by speed. But remember, this formula is used only when speed is constant. And you all can see that this is the example of uniform circular motion. Uniform circular motion. Why? Because force of gravity and V, angle between these two is what? 90. This gravitational force, which is acting perpendicular to the V vector, cannot increase magnitude of the speed. I hope you remember from circular motion there were two components, one was tangential and the other one was centripetal. Since there are no tangential forces present, speed will remain same, which is called what? Uniform circular motion. In uniform circular motion, velocity is not constant, direction is continuously changing. What is constant? Speed, and therefore I can use this formula. What is the distance of the satellite is going to travel? 2 pi r. 2 pi r. With what speed? VO. That's your t. You have the value of V. Put it here and you get your time. T is 2 pi r divided by V O, which is root over Gm by r. And what is this? This is 2 pi root over r cube divided by Gm. आर क्यूब डिवाइडेड बाय gm। लेकिन ऐसा ही लोग तो यहां भी है, होना भी चाहिए था। क्यों? व्हाट इज ओमेगा? ओमेगा इज 2 pi divided by t. What is speed? Displacement divided by time. This is angular velocity, which is angular displacement divided by time. Angular velocity is equal to what? Angular displacement divided by time. What is the angular displacement? As you complete one round, what is the angular displacement? 2 pi. So you could have answered t directly using omega also. T is coming 2 pi multiplied by r cube divided by gm. Same answer. दोनों चीजें सेम ही है, बोलने का तरीका अलग है। यहाँ आप एंगुलर करके डिफाइन कर रहे हो, यहाँ पर आप सिंपल डिस्टेंस वाइज डिफाइन कर रहे हो। Note down this. And I hope everybody can see that this is t 2 pi r cube gm. 2 pi is a constant, gm is a constant, make a square and it becomes t square proportional to r cube, which I hope you remember is Kepler's third law. Square, constant, constant r cube. T square is proportional to what? R cube. So if they ask you that develop or prove Kepler's third law using Newton's laws, then you will be doing what? You will find out orbital speed with the help of gravitational force and then go for finding t square, and you have proved Kepler's third law with the help of Newton's laws. Put on this. Now, tell me this, if we increase the mass of satellite, then what happens to orbital speed? If we increase the mass of satellite, if you double the mass of satellite, then what happens to orbital speed? It increases or decreases? And everybody can see that it remains what? Same. Why? Because this m is mass of the planet around which your satellite is revolving. Small n, which was mass of satellite, is not present in this. So write down this as a statement again. Orbital speed is independent of the mass of satellite. Orbital speed is independent of the mass of satellite. Now, answer this. Which one is moving faster? Earth or Saturn? Which one is moving faster around Sun? Is it Earth or is it the planet Saturn? Answer this in the comment box. Earth is closer and therefore is moving faster. You can answer these questions on the basis of this thing. Which one is going to take longer time, Earth or Saturn? Answer the second part. Which one is going to take longer to complete one rotation? Is it Earth or is it Saturn? Further you are away from the sun, longer it will take you to complete one rotation. And therefore, answer for the second part is what? Saturn. Answer this question. Suppose, let's say we have a new planet around Sun and call it planet X. This planet X, question says, is at a distance of 8 times than that of Earth from the Sun. Then the question is, find out duration of 1 year on that planet. Let me repeat my question. Write down the question. A planet X around Sun revolves at a distance of 8 times that of Earth from Sun. At a distance of 8 times that of Earth from the Sun. Find out duration of 1 year in terms of Earth's year on that planet. This is Earth. This is planet X. This is Sun. This is R. This is 8R. Distance from the Sun. The question is, what is the duration of a year So it looks like question is a bit difficult, but it is not. So when I ask you that, what is the duration of a year over here for this planet X, then the meaning of 1 year for us is what? The time in which Earth completes one full rotation. This is called what? 1 year, which we know as 365 days, 1 day of 24 hours. So if you ask an astronaut, let's say who is present at this planet X, that what is the length of 1 year, then it means you're asking him in what time your planet X has completed one rotation. So you're asking him what? You're asking him this. You're asking him find out Tx in terms of Te. What is TE? You're asking him TX, and TE is what? 1 year. 1 Earth's year. Simply write 1 year, which is 365 days, remember. So TE is 1 Earth year. TX we need to find. Use this and you'll get the answer. How do we use this? TX upon TE square is equal to what? Rx cube RE cube. That's what we need to find. This Rx upon Re is what? 8. This is cube of 8. Eight R upon R got cancelled. This is what? 8 cube. So your Tx is coming 8 to the power 3 by 2 square root of Te. And what is Te? 1 year. So the answer is what? 8 to the power 3 by 2 Earth's year. So duration of 1 year at that planet is what? 8 to the power 3 by 2 of Earth's year. Now, find out our next thing. Find out total energy of a satellite in its orbit. Find out total energy of a satellite in its orbit. When I say total energy, it means total mechanical energy of a satellite in its orbit. Let's say this is Earth. It can be Sun, it can be Earth, it can be any planet. We are interested in energy of this satellite, which is moving with VO. Its mass is m and distance from the center of the planet is r. You need to find total mechanical energy. What is mechanical energy? Sum of kinetic and potential. Do this and you'll get the answer. भाई सिंपल वैल्यूज पुट करनी है आपने. What is kinetic energy? Half m VO. What is potential energy? अर्थ टाइप के सिस्टम के लिए mgh यूज नहीं होता. Minus of gmm upon what is the distance? Small r. This gives you what? What is the value of VO? Root gm by r square gm by r. This is coming minus of gmm divided by 2r. Take minus gmm by r common and you get 1 minus 1 by 2, which is half, and your answer is minus of gmm by 2r. Important result. I have told you that we need to prepare at least 2000, 3000 results. This is one of those results. And we have developed so many results in this chapter. Time period, omega, orbital speed, escape velocity. It looks there are 3, 4, 5, 6 different results, but they all are interlinked. Hold on this. Write down a question. This question is again good for both school as well as competitive examinations. By what factor orbital speed of a satellite should be increased? By what factor orbital speed of a satellite should be increased so that it can escape to infinity? By what factor orbital speed should be increased so that a satellite can escape to infinity? Should not take more than 30 seconds. Good. Outside. Suppose escape velocity of the satellite is VE. What was VE? This is VO. No, this is not VO, this is total mechanical energy. So, this is VE, and with VE when you throw it, it cannot complete one round, instead it will move like this. If you throw this thing with VE, it will move like this. You can remember it for your knowledge. This is parabolic trajectory. If you throw this object with VO, then trajectory is what? Circular. If V is what? VO. If V is made VE, it follows this parabolic trajectory and reaches infinity. Now, what is the formula for VE? Formula for VE was root over 2 gm by r. लेकिन ये कब था? जब आप कहां पर थे? अर्थ की सरफेस पर. इस बार आप कहां पर हैं? सरफेस से कितने डिस्टेंस पर? Small r. Not surface, from the center, and therefore instead of taking capital R, simply use what? smaller. Otherwise, you need to write what? Ke plus p at this place. Ke plus p half mv square is the Ke. P minus of gmm by r. At infinity, it becomes 0, it becomes 0. VE, half mv, potential becomes what? 0. And you get the value of V. Or you can save time. We have the value of V when object was thrown from the surface. In that case, this thing was capital R. Simply replace it with small r. Now this is V, but you can see that this V is root 2 times VO. Gm by R is what? VO. So if you increase orbital velocity by a factor of root 2, 1.414, then object will follow a parabolic trajectory. This is another result you can remember, and it will reach infinity. This question is also asked in this form. I'll take just one more minute and let's see if you can produce a correct answer also. Right now I asked you by what factor orbital speed should be increased. You can also ask you this way, by how much percent orbital speed should be increased so that an object can escape to infinity. Now I'm asking you percentage change. You've got 30 seconds fast, if you can find the percentage change. By what percent orbital speed should be increased so that your satellite reaches infinity? Now, formula for any type of percentage change is final minus initial divided by initial into 100. That's how you find percentage change. Final, initial into 100. If you are using this formula, then before increasing, it was moving with VO. Before increasing the speed, satellite was moving with VO. This is your initial. And when you make it VE, which is root 2 times VO, that's your final. And you make it root 2. Question is what? It is moving with VO. By what percent you need to increase? This is the final part. Multiplied by 100. This is coming 41.4%. Root 2 is 1.414 minus 1. VO cancel. You get what? 41.4%. So if you increase orbital speed by 41.4%, satellite will escape to infinity. If you understand everything, write down yes in the comment box and then you can leave. Thank you very much.